Thank you. Well, glad you made it to this room, and thanks for attending my presentation. As you see, I work at Nixu. Nixu is a Finnish company who decided to set up shop in the Netherlands as well, so we recently opened a branch here in Amsterdam. Well, my talk is about a series of unfortunate events, which refers obviously to a book series authored by a guy with the alias Lemony Snicket. Or you probably know the movie with Jim Carrey as a bad guy, Count Olaf. So I saw a few parallels in a case of a ransomware incident, so I thought it was neat to steal a few pictures from the movie. Ransomware, it's not exactly a new phenomena. About a decade ago, criminals realized that there is a nice business model in not just destroying files, but be able to reverse the process. Of course, after paying up a ransom fee. So apparently they beta tested for a few years in Russia, and since 2012 it spread across Europe and the US, so it obviously is mature enough for us to consume this service. Well, the thing about this service is even if you pay the ransom, there's no guarantee that you actually get your files back in the end. Well, in this case, I hope that they got their files back because they paid $70,000. This is the Hollywood Presbyterian Hospital, who was hit by a case of ransomware. Yeah. That was a pretty bad case. I think it's at least it's a case that's publicly known. Well, it usually starts with something like this, unfortunately. The help desk gets a phone call. Well, we have some strange looking files here on this file share. I am unable to open it in Word or Excel or whatever. As you can, it's hardly readable, I think. But the files here have a strange extension, which is alluding to the email address that you should contact the kidnapper, and hopefully after paying you get your files back. That happens, I heard in a talk yesterday, in, well, 3%, if I'm correct, of the successful ransomware infections. So this business model obviously works. Well, in this particular case, this was a huge file share. At least 600 gigabytes of files were encrypted, at least partially encrypted. In this case, the first 15K of a file were encrypted, so that's just enough to make it useless. And sometimes you get notified that and sometimes you just get notified by an end user, which is pretty bad. So that means that your first line of defense already has failed. So your AV solution has failed. Your intrusion detection, prevention, whatever has failed already, and the kidnapper hostages your files now. Sometimes the ransomware leaves a ransom note on the desktop, but that's not always the case. And even if an end user sees a ransom note, he's often reluctant in reporting. Let's take one step back and see, let's take a look at the incident handling process, which is also useful when having a case of ransomware. So as far as the preparation phase goes, you should not confuse that with the prevention part, because it obviously already has failed, your AVE has failed, etc., etc. But the incident response process, the preparation is all about thinking of everything what could go wrong and how to respond on that. So think about, for example, an arsenal of tools you're familiar with that are useful in handling the process. The level of access, you probably as an incident responder need to talk to the business, to IT, to elevate your privileges in order to investigate the issue. You probably need admin level access to servers. It's a good idea to be trained as a professional, so you know what to do when the ransomware is in the process of encrypting your entire file share. Sometimes you have to deal with regulatory bodies, like for instance here in the Netherlands, we have a breach notification law that was introduced earlier this year, and that states that you should report any incident where it potentially concerns data or information about persons. Because you cannot rule that out in advance, it's probably the best bet to report that, because you may get a huge fine if you omit that step and the shit hits the fan later. Well, the preparation phase of some companies is just as much as having a sticky note on their screen with a phone number who to call when there are problems. So that's good for our business, of course. But the flip side is that the responder enters the case at a very late stage. So obviously most evidence is already gone, and you get stuck with a huge pile of files that are encrypted. Sometimes, if you're lucky, there exists free tools to reverse that process, but that's not always the case. What is important is, if you're a first responder, that you make sure that you collect as much information as possible. So it's very useful to locate patient 0, the original infector. So if you have a sample of the malware, you can analyze that and see if it communicates to a command control infrastructure, and you can take some measures, probably at the network level, to block a certain range of IP addresses or whatever. So let's see what you can look at. If you happen to have access to the file server, remember that you need to arrange that as part of your preparation. You could take a look at Netstat open connections. Obviously, when encryption is in process, it's encrypting files on your file server. You have a lot of open connections from a single host that is infected, so that points you in the right direction. Also, the open files command is very useful. That even points you to the user name that has been infected. If the encryption already has stopped, you can turn to less volatile data and take a look at the firewall connection logs if these are available, which is also not always the case, or net flow data. So there's no guarantee that you can locate patient 0 or get that sample of the malware, because it often destroys itself after having done the dirty deed. So if the process is still ongoing, you want obviously to prevent it from getting worse. So you might be tempted to unplug the network cable from the file server, which might seem a good idea, but you destroy some volatile information, so I recommend that you take a look at the netstat data first. So there are some other things that you could do after the encryption has stopped, but there might be a problem that it reappears if you're not able to fully eradicate the ransomware. You have to be as early as possible. You need to be notified of a new encryption round. So what you could do is use, for example, a file service resource manager file screen feature, which is actually really neat. You can configure it to alert you when new files pop up with a certain extension or a certain pattern. Or alternatively, you could configure file system object auditing. Here's a link which has a pretty neat idea of actually creating a symlink-like folders on your systems that loop back to itself. So if the ransomware descends into a certain folder, it hits the symlink to the same folder and obviously will starve from resources or die and effectively stop the process. Other ideas: blocking the command and control traffic. One thing you have to remind here, if you use the symlink approach, you might run into trouble because some software, for example, an AV scanner, when you perform a full file scan, will fall into the same trap. So it may die as well, so be careful. Unless you have enabled volume shadow copies, you probably need to rely on a traditional backup, which often means it's a day old, or best case. So what is sorry. So it's important that if you have a set of known good files, you don't want to overwrite the files that have not been affected by the ransomware. So you must do a selective restore, and that might pose some challenges. So first thing you can do is identify the files that were actually affected in the first place. So in this particular case, it was pretty obvious because the files were renamed. I don't know if you can read it. Ah, there it is. The email address, decode@india.com, of the kidnapper. So a first step at this is just running dir s command to descend, to recursively list all files. Well, that in this example, we have 924 files. but in the real case, this was more than 50,000. But there is something weird going on here, because if you use the file explorer to filter on this file type, you end up with 30 more files. So that's interesting that we have this discrepancy. So perhaps DOS had seen his best time, so let's try PowerShell, right? So this is actually the same listing, and again 924 files. There are still 30 files missing. PowerShell is actually fairly helpful here because it's unreadable, I know, but trust me, it says something along the lines of file path must be less than 260 characters in order to display. So, all right. That's obviously a problem. The ransomware was able to descend into a folder structure which caused the file path to exceed that limit. And if you browse the Microsoft website, you find this limitation, which is pretty disappointing for a modern operating system, because the NTFS file system, for example, supports file paths up to 32,768 or something characters in path lengths. So it appears to be the problem in the underlying API for basic file I/O, which dates back to good old DOS times. At least when the rumor is that a certain person in Microsoft said 640 kilobytes is enough for anyone. So you would say they're probably able to lift that problem. Yes, you could do that at the API end, but, well, applications, not so much if they reserve only 260 characters and the file name exceeds that size. I don't have to explain you what a buffer overflow can do. So that's probably the reason Microsoft didn't touch that part of the Windows API. So how can you circumvent that problem? Yes, well, DOS is actually useful here. I don't know if you've, I see some people with gray hair who probably remember the subs commands. Actually, you can alias a folder name with a drive letter. So if you have a really long directory name, you can just call it a freely available drive letter and refer to that as well. And, well, there are your files. Another problem you can run into is while you're trying to identify the files, that even if you have administrator privileges, you cannot access these files. And that probably has to do with something that administrators sometimes should not be able to read all files, for example, human resource information, etc. Whatever. So you could easily resolve that with use the iCackle's command line tool that has a take own option, which will take ownership, so you have access in the end. But the problem again is that 260 character path limitation. So yeah, you can use a substrict to circumvent that. But it's very cumbersome. So we have actually a tool that is built in since Windows 2008. It's called ROBOCOPY. Very convenient for copying entire folder structures and doing all kinds of cool stuff. And with this simple trick, you can list all files and it has no path limitation. You actually solve another problem, that the ownership problem. You don't have to take ownership because it uses the Windows backup privilege, which allows you to bypass the ACLs that are set on the files. So, yeah, very cool actually. So, a cool thing would be to combine both PowerShell powers and ROBOCOPY powers. There's a nice blog on this. Yeah, you can take a look yourself. It was a blog post by Bo Prox, which who is some PowerShell guru. And well, I thought, well, I like to expand on that idea and build a full PowerShell module with tools to identify this type of files when you have a ransomware case. So what you typically want to do is to restore your files, but want to do that selectively. There are not many backup solutions that allow you to feed a text file with a listing of file paths to actually do the selection and to selectively restore those files. But, well, maybe we can abuse ROBOCOPY to do that. It takes file paths and single files, but you have to combine that, and PowerShell is very convenient to do that. This actually was the good news in this case. You have a one-day-old backup, but the volume is pretty large and the WAN link is pretty limited. So it would take a little over 35 hours to restore over the network. Not good. So you can actually save some time by performing a full restore to a local drive. Yeah, obviously you need to select a fast drive, so not just something that's probably an old USB 2 crappy drive. But anyway, in this case, the restore throughput was between 25 and 30 megabytes and took 4 hours, which is acceptable considering that the expedition took 1.5 to 2 hours. So this is a famous quote, I don't know if you can read it, by Andrew Tannenbaum. Never underestimate the bandwidth of a station wagon full of tapes hurling down the highway. Well, obviously we are using a portable hard drive nowadays, but it's still applicable. So, we're done, right? Well, apparently, a few days later, an end user calls, well, I have this strange file. It looks all right, it's a Word document, but I'm still unable to open it. It's garbage. And it appeared that the ransomware actually was successful in encrypting the file, but unsuccessfully in renaming the file because it hit the same 260 character file path limitation. So back to the drawing board, or actually back to the PowerShell module, and try to come up with a method to identify these new files. Well, PowerShell is great in parsing stuff, and especially dates. So it was convenient to select, make a sub-selection of files that had been modified during the period that the ransomware was active. But it still contains a mix of files that were actually edited by users and the ransomware. So it's a little bit better, but still not satisfying. So next thing I did was, well, try to identify encrypted blocks. We know that the first 16K was encrypted, so we expect a high entropy there. A single block, and after 16K or so, entropy was fluctuating depending on the contents of the file. So I hacked that into the PowerShell module and was successful in restoring all files in the end. Recovery from a ransomware incident can be quite complex, actually, and it really pays off to be well prepared. So you should consider the scenario where you will never find the original infector. You should consider the fact that there is no decryption tool available, so you have to rely on your backup procedure. So I suggest to do an exercise to see if you can still meet your recovery time objective when needing to perform a selective restore. You might consider some prevention, or at least, in addition to the preventative measures, improve your detection capabilities by using the file share canaries we saw earlier in the slide. And, that's about it. So I'll take questions now. No questions? Okay, thank you.